Welcome back to our problem solving series with 2, question 3. In this question, we are asked to find the y on the x, given that tan xy plus e to the y equals x cubed plus y ln x. So the first thing we need to do in this case is to recall the different steps or procedures we need to follow in order to apply implicit differentiation on this question. So what was our first step? Our first step was to first of all determine or to analyze if we already have a function in terms of y and x. So in this case, we already have a function in terms of y and x, as it is evidenced in the case that we have terms in terms of y and x. For example, tan xy, which is a function in terms of x and y in x, which is a function in terms of y and x. We have x cubed here, which is a function in terms of x, e to the y, which is a function in terms of y, all of that mixed in the same equation. This already tells us that we have a function in terms of x and y. So what's the next step? The next step is to apply differentiation with respect to x on both sides of the equation. So let's work that out. This leaves us with d on the x of tan xy plus e to the y equals the d on the x of x cubed plus y ln x. Opening the bracket, we have d on the x of tan xy plus d on the x of e to the y equal to d on the x of x cubed plus d on the x of y ln x. So let's start this step by step, just like previous example, taking term by term. So let's start with our first term, d on the x of tan xy. So what's the first thing we notice? The first thing we observe is that this is a function of another function, with our inner function being xy and our outer function being the tan function. And this already tells us that in order to differentiate this, we need to use the chain rule. But what does the chain rule tells us? The chain rule tells us that if you have a function that is a derivative with respect to x of a function f of g of x, this is same thing as f prime of g of x times g prime of x. So the first thing we're going to do is let u be our inner function x, y. This implies that our outer function can be written as, or f of u can be written as tan of u, implying that f prime of u, which is the derivative of u, is the function derivative with respect to u, in this case, yes, of tan of u. And recalling from our differentiation of trig function, the derivative for the function tan x or tan u in this case is sec squared u. So this then implies that f prime of u, which is f prime of xy, is equal to sec squared of xy. So let's then move on to our g prime of x. Now we let still u be equal to g prime of x, or we could directly say u prime. This implies that u prime, which is equal to g prime, is equal to the derivative with respect to x of our function xy. When we look at this function, we notice that this is still a product of a product, right? The product of two different functions, sorry. And when we have the derivative of any function which can be written as a product of two different functions, with our first being x and our next being y, the first thing we have to recall is that in order to calculate this, we need to use the product rule. And what does this product rule state? It states that the derivative with respect to x of two functions multiplied by each other, uv, gives us u dv plus v du. So first of all, what's our u, what's our v? We let, or what we already use here, let's just let small u, yes, or we use a and b in our case. Let a be the function x, implies that a prime is equal to 1, and let b be the function y, implies that y b prime is equal to dy, on dx. This implies that g prime is equal to u dv x dy on dx plus y times 1, which gives us x dy on dx plus y. So we can then conclude that our function this, which is f prime of g of x times g prime of x, that is sec squared of xy times this, gives us that is the derivative with respect to x of tan of xy, gives us sec squared xy into x dy on the x plus y. Opening our brackets, we have x sec squared xy dy on the x plus y sec squared xy. So we can then conclude that the derivative with respect to x of the function tan of xy leaves us with x sec squared xy dy on the x plus y sec squared xy. We label this equation 1. So let's move on to our second term. What does our second term ask us to do? It asks us to differentiate the function power y. The derivative with respect to x of the function e to the power y is same thing as the derivative of y with respect to x of the function times, derivative of y with respect to x times the derivative of our function e of y with respect to y. This can all be evident to the formula. The derivative with respect to x, that's the general expression of any function of the form f of y, that's any function with respect to y, or any function dependent on y, is dy on the x times the derivative that our function with respect then to y. So this gives us dy on the x. Now what's the derivative of e of y with respect to y? We call it exponential derivatives. The derivative e to the power x with respect to x still gives us e to the power x. So this tells us that the derivative of e to the power y with respect to y still gives us e to the power y. So we can then conclude, implies that the derivative with respect to x of our term ey gives us e to the power y dy on dx. We label this equation 2. So let's move on to our third term. Our third term in this case asks us to differentiate x cubed. This is very simple and direct. The derivative with respect to x of the function x cubed gives us 3x squared. We label this equation 3. Moving on to equation 4. Moving on to our fourth term, which tells us to derive the function y in x. That is the derivative with respect to x of y in x. So what's the first thing we observe here? We observe that this is still a product of two different functions, with our first function being y and our second function being x. Recalling the same formula above here, the derivative of the product of two different functions can be written as u dv plus v du. So first of all, what is our u and what is our v? We'll let u be the first function y, implies that u prime, which is the derivative of y with respect to x, and this gives us dy on dx. We will also let v be equal to ln x, and this implies that v prime, which is the derivative of ln x with respect to x, and this gives us 1 on x. Responding the video on the derivative of logarithmic functions. It was well stated and well proven that the derivative of ln of x gives us 1 on x. So this implies that the derivative with respect to x of our function y ln x gives us u dv y times 1 on x plus v du. U dv plus v du. Our v being ln of x times du dy on dx. This gives us y on x plus ln of x times dy on dx. So we can then conclude that this implies the derivative with respect to x of our function y ln x gives us y on x plus ln of x dy on dx. We label this equation 4. So we are done with calculating our 4 different terms. What's the next step we need to do? To substitute these 4 different terms or these 4 different solutions in our initial equation. So substituting this will leave us with our first term, that is term 1 plus term 2 equal to the third term plus the fourth term. So let's start. What's our first term? Our first term is x sec squared xy dy on the x with braces x sec squared xy dy on the x plus y sec squared xy. That's our first term, plus our second term being e to the power y dy on the x, e to the power y dy on the x equals, so our third term being 3x squared 3x squared plus our fourth term y on x plus ln x dy on the x. Let me put this where this doesn't look that much as ln. Yes, that is it. So in order, after applying this or after calculating our different terms and substituting the general equation, the next thing we need to do then is to use algebraic laws or algebraic principles in order to find the one's x. The first step we need to do, or the first thing we need to do, is to move all the terms containing dy on the x on one side of the equation, that is making dy on the x the subject of the formula. So what is the first term? X sec squared xy dy on dx. Our next term plus ey dy on the x. Our last term, which is this, is on the other side. So moving into the other side, to the left hand side, the plus becomes a negative, leaving us with ln x dy on dx equal to our next term. We need to move it to the other side, minus y sec squared xy plus 3x squared plus y on x, that is plus this plus this. Now on our left hand side, we factorize dy on the x out since it's common throughout the three terms, leaving us with dy on the x in bracket x sec squared xy plus e to the power y minus ln x, all that equal to 3x squared plus y on x minus y sec squared x. So this then tells us that dy on the x is the term 3x squared plus y on x minus y sec squared xy, all divided by x sec squared xy plus e to the y minus ln of y. So in conclusion, therefore, the derivative of y with respect to x in this our term, in this our question, gives us the equation or the expression 3x squared plus y on x minus y sec squared xy divided by x sec squared xy plus e to the y minus ln x. We enclose or box our answers. So thank you for being with us throughout this video, throughout this calculation. Hope you guys have understood step by step. If you have any questions, feel free to post them in the comment section below, and I'll do my best to respond to them. So thank you and see you in the next video. Bye.